Hello, Internet, and thank you very much for tuning into the Cloud Native FM podcast. You are watching this YouTube channel, and today we ask a simple but brutal question. Is Kubernetes enough to run modern AI workload at enterprise scale? Spoiler alert, it can be great, but only when paired with tools that are purpose-built for LLM inference and app integration. Today, we will look at the gaps and the promising open source approach LLM-d provide. LLM-d is a new open source project for the high performance distributed inference on Kubernetes. It can provide the little path for anyone to serve large generative AI model at scale with the fastest time to value and competitive performance per dollar for most model across most hardware accelerator. But I am absolutely new to this project. I've heard this, I think, 3 weeks back for one of my friend. So now I have a maintainer and a very exciting team in front of me. So thank you very much for joining you both. So let's go first with the Cedric Clyburn for your quick intro.
Hey, yeah, thank you, Sam. And what a great introduction. I think we're going to learn a lot, not just about LLMs today, but operationalizing the platform side. And myself, I'm an engineer. I'm a developer here at Red Hat. I've been working on container tools for a while, and then I guess I got upgraded to Kubernetes a few years ago. And now I do developer advocacy, and I'm joined also by my peer, Christopher Nuland.
How are you?
Yeah, hey. Yeah, it was great being here. My name is Christopher Nuland. I am an AI architect here at Red Hat, primarily working around inference. My background here at Red Hat goes about 8 years, where I was deploying AI workloads into a variety of distributed builds within Kubernetes, so our OpenShift platform. And the last 2 years, I've been focused more on the technical management side and enablement side of our AI inference tools. So right now I am part of the team that's working with LLM-d heavily, and both from a Red Hat perspective, but also a community side. So I'm working a lot with our observability team and also the side that's doing a lot with the advanced scheduling that we'll talk a little bit more about here in a moment.
Absolutely, wonderfully. And I think a ton of appreciation for the Red Hat team over the year, because the Cloud Native Computing Foundation, they build up some wonderful innovation from some very good project. Every good project, if you look at the repository, that there are the main contributor comes from the Red Hat team. So their team is always been a very flourishing and very skillful team in the community as well. But what we like to call here is today is all about the need, what the enterprises need for the AI workload as well. We ask question from, is Kubernetes is a good solution to run AI workload? If it is, what are some of the stacks offering we have, and how we can actually congest our stack, because the cost is skyrocketing at this moment of time. There is a subscription model being always more expensive than ever in the cloud. And as a community, as an enterprise, as an individual customer, we like to trim our costs down. So we'll look forward to see how some of the approaches exist in the market today as well. But for my first question, anybody from you who can actually take it, tell us some of the motivation behind LLM-d project. And number one, before that, tell us how long it's been there in the market. It's been there in the community.
Yeah, I can take a stab at that. So this is actually a fairly new project. A lot of the thought leadership of this project came out of a lot of the work that was happening in another open source project called vLLM. So vLLM is a very popular inference tool that you can run either locally on your desktop or laptop, or within a DGX cluster. So it's meant to really optimize your AI inference workloads around things like caching, distribution, a variety of speculative decoding. There's a variety of ways that we use to optimize a model. But the challenge that we're having actually in industry right now is that you can actually kind of take this back to some of the same challenges we had in the early aughts around just regular applications. and that is these AI workloads are starting to become more monolithic in size. So we have things like observability entrenched into it. We have different types of configurations. We have different types of so layers and pipelines happening all within this one container. And the challenge that we were seeing is, well, how do we effectively distribute this across a cluster like within Kubernetes? Because right now it's very much like round robin. You just spin up a whole new instance of vLLM. Well, now you're copying all of that content, and sometimes it doesn't need to be copied. Sometimes you would only want to copy like a small fraction of it. So the idea here is really breaking up that container and the LLM into its parts and making that a first-class citizen within Kubernetes. This allows us to scale different components of the LLM and even do things super cool stuff like there's a, and we can go into more of the technology kind of later in this podcast, but there's ways that we can actually split it up and actually assign like GPU in one component and even CPU on another component that may be more CPU optimized. So a lot of the ideas around this was because of these challenges that we're seeing in industry, the need for LLM-d. And I've been told some of the conversations happened at KubeCon EU this last year in London. And then it was a follow-up conversation between Red Hat, Google, and IBM primarily, where we recognized a need to fix this situation that we were seeing. We were seeing these large language models balloon, but the ability to actually distribute them effectively or disaggregate them just wasn't there within vLLM as a community. And the decision was, well, will vLLM solve this themselves? Well, that would make vLLM a little bit more complicated. It would kind of take it out of its core charter of what it's trying to achieve. So what we realized is that we actually needed a new community focused just around this disaggregation of the AI, splitting this AI up into its parts, making it a first-class citizen within Kubernetes and optimizing. And since then, we've had a number of AI accelerators like NVIDIA and AMD join the project. We've seen model AI labs like Mistral more involved, and that list just keeps growing. So this isn't just a niche Red Hat project. This is probably one of the biggest projects I've seen in the open source community within the last few years, where we've seen all the heavy players in industry come together around this single concept of LLM-d and solving this problem.
Yes, absolutely. 100%. If you look at the repository today, and I will link those in the YouTube description so people can see what we're talking about here in the podcast. And as you mentioned, it's rightfully so. These are the very big companies. I think for a very long time, for one project, all of the biggest vendor in the community in the market are actually coming together to solve this very big problem that is actually been hitting today as well. Can we look at the LLM-d as when the Kubernetes initially came up is kind of a bloated, and then we actually come up in a point where we actually start added more distribution into the Kubernetes, like K3s, MicroK8s, Minikube, and bunch of all these smaller is in ability to run Kubernetes not just in the cloud, but in the laptop environment or in the edge devices or all in the different devices. Can we say that's the same philosophy for a LLM kind of a capabilities, because these LLMs are kind of a huge, as you mentioned during the conversation, because these are not small things. These can be quite complex, and if you run them on one pod, you need a tremendous amount of CPU, GPU, and memory. And let's be honest, not all the enterprises has those costs to run those LLMs. So it's a really unique case, like you can distribute those and run some functionality on some compute devices, and sometimes you don't need you can actually distribute in a way that the cost can be trimmed down as well. So I think in theory it's look like a very very good use case, and also it's looked like a very good problem to solve as well. But I go back to the Cedric because I think in a community, I've seen a lot of debates happening, and I will ask your opinion as well because Red Hat is also the open shift, and they have also wonderful enterprise customer community back in the day behind the scene for all of different projects. So Cedric, if somebody asks you, is Kubernetes is a net fit for the AI workload, how you can actually look at this in a full equation?
Yeah, man, that's a great question as well, because I think all the time about developer experience and what I myself or developers around the world would go to if they're trying to build an AI application, right? And so typically, if you think about, hey, I want to get started running my own AI, I don't want to pay for some type of third-party LLM and send my data there, right? I'll typically get started with like ollama or Llama C++ or one of these upstream projects that are compressing, they're quantizing this LLM. So you could think of GPT-OSS, or you could think of DeepSeek or something like that, right? And so I kind of think of that first stage as kind of like a developer working with Docker or Podman, right? And so while they're still working with containers, right, they're using a different container runtime, and that's a different process than when you're using like Creo or one of the container runtimes for Kubernetes, right? So I think of that local kind of developer experience, and then moving to have more, capabilities, right? When in terms of demand of my application, in terms of observability, in terms of tracing and metrics, and that's all the capabilities that we have with Kubernetes and Prometheus and Grafana and that ecosystem in the CNCF, right? And so I think of there's that kind of path, and then once you actually get there, as Nuland was talking about, right? If we're running all of these LLM instances, right, these runtimes with vLLM or say another provider like that in one container, and we scale things up, what happens is that our LLM requests are being pretty inefficiently used when it comes to resources, right? Because let's say you have, if we're building an application, you got RAG, right, where you ask a question on all your documents. You have a teeny tiny question, and then you've got this much context and information, right? Or agentic, hey, I have a question, and I'm getting even more response back, right? So it's not very a uniform of a request. And so if we can use Kubernetes features in order to disaggregate and kind of split up that request in capacities of GPU and CPU and memory utilization, then we can really tap into the power of Kubernetes when it has or at least for scheduling those resources, right? And that's the true use case. And so that's at least how I see it in terms of flow, but also in terms of using the capabilities of Kubernetes to run AI, right?
Yes, 100%. Absolutely. I think you pointed out rightly so, because I think Kubernetes is not just a project or open source tool. It's an ecosystem that is bringing to it with as well. Like if you run a CI/CD pipeline, that the Kubernetes already has some tools available for you. You need to run a GitOps as a reconciliation loop with them. Yes, you have tools available for them. And also in a regulatory setup, nobody want to give data to some random third party to train LLM and run those inside some of the cluster. You need to have policy and governance. And yes, Kubernetes has some solution for it. And as you mentioned, monitoring is a big part to any enterprises or any customer, because they need to know what's happening, why it's happening, and when something is down, why it's something down, and what I need to do in order to bring them back. So all those capabilities are available in the Kubernetes. So I think it's a natural fit for the AI workload. I hope more and more people realize that the gigantic ecosystem that brings into the Kubernetes, it's a really powerful paradigm shift for the AI workload, because AI is not just a tool you can run anywhere. You need to integrate it with what's already been happening in your stack, in your application. And remember, some applications are way older than what's in the market or what's in the community out there as well. But I will go back to the Christopher Nuland once again, and I'll ask a very generic question here, because if you look at the Kubernetes ecosystem, we have CRI, we have CSI, we have CNI, and we have so many standards and implementation of the APIs is valuable. So, but right now, I think it's a very, very it's too early to ask these kind of a question. But kind of we think around if we progress with the LLM-d project in the near future, would we imagine an environment, would you imagine a scenario where Kubernetes built in an integration for AI or LLM, whatever the logic you have, you can call the Kubernetes API, it hook into it, and then you don't need to swap anything. The back logic works as expected. So you'd think kind of LLM is heading toward that path, or if it's too early, like if it's too early, like what's the LLM-d main purpose in the Kubernetes ecosystem?
Yeah, I think this is a really fascinating question, because I think LLM-d is bringing in a lot of those types of core features. We're not just looking at the inference layer, which is really what separates it from like vLLM, for example, as a project. We're instead looking at it as the big picture of how does distributed AI work within Kubernetes. And I think, to your point, a lot of that is happening at a gateway and an API layer. So traditionally we have like your just standard gateway going into an application, and it's usually round robin. It's working off of metrics that are CPU related, traditional memory, HTTP requests, and all that's being driven by also like the API and pulling all that information. LLM-d is looking at the new paradigm, and that is what metrics are important to an LLM, and how does routing now look like, and how does an API also look like when we start moving into that new paradigm. So things like time to first token. So how long does it take for your LLM to actually start giving results? Or token throughput, which is like basically the time between tokens. You may have heard that other phrase too. And those are like two examples, but other ones that we're actually starting to just come up with now, like LLM-d is starting to, take note to things like cache hit rate. How often are we hitting the cache of the LLM? That's actually a really critical metric. It can really reduce costs, orders of magnitude, when you start optimizing around the cache. And a lot of that is happening at this API gateway layer. So popular projects like Envoy, for example, is embedded into this. And then we have custom, what we call we have what we call 3 well-lit paths. And I'll talk about this first well-lit path is scheduling and routing primarily. And what we're doing is we're making the Kubernetes aware of the request. So what we call prompt aware request. So when you're actually making a request to the router, the API, it actually knows where these requests should go. So if you have 3 LLMs configured with LLM-d, the example I always give is let's talk about like mixture of experts, for example, where a model over here might be an expert in physics, and this is English, and this is history, for example. The router will be aware if you're asking a question about Albert Einstein and what is E equals mc squared. Well, more than likely, it's probably going to go to the physics section. Could still be history. We're going to cancel out English. But because now the router is prompt aware, it can start making decisions on where it wants to route based off of where the expert might be located. If we're talking about like an expert model like DeepSeek or GPT OSS, for example, where each of those experts are running in their own machine or node within Kubernetes, and actually have a significantly higher chance of hitting a cache hit as well. So because all the physics questions are over here, we know that the cache is heavy with physics questions, and we have a much more likelihood of actually hitting that cache based off of what we have managed. We have basically a stack in the router layer that's aware of what has come in previously and how it's been routed. So instead of traditional round robin or sticky sessions, where sticky sessions, do solve some of those problems, but now you could end up with 60-70% of your traffic going to one LLM and still hitting that issue of cache rate and cache failure hit. Instead, by having this new approach, we can optimize and actually see orders of magnitude savings, especially on systems where there's high demand. So if you're having thousands of requests per minute, so to speak, that would be a prime example of where you could be optimizing around something like LLM-d for within your Kubernetes cluster.
Yes, absolutely. And I think if anybody hurting to this, because these are the very universal problem in the landscape currently, and we don't have any much of the solution in the table. And sometimes it's a scratch need, like let's build it out. And remember, and remember, you have some already customer in the queue. You're solving their problem, and there's a need to solve their problem. You build something from the scratch. That model doesn't work. You need some of the community version to have accelerated adoption for your product itself. But it's a very, very, as you mentioning during the philosophy of the tool, I think it's really resonated for me at least. We'll see how the people in the community react to this LLM-d new approach as well. But for the next phase, I kind to ask a very generic question here is, when you work with the tool, there's naturally a developer's workflow for some of the tools, or even the ops workflow is that. So currently, if I look at the market, there's a tools called KitOps who can actually bind all of these pipelines and make an OCI artifact layer approach for your LLM to run the inference, because running an LLM in a different devices, it's always been a big challenge. It's a huge challenge. I think we haven't able to figure it out, but the KitOps is a good approach for there as well. But is a kind of a question here is, what is a developer workflow for the LLM-d? What I usually do is I build my application in a container image, and then I can hook those containers to registry and put that image into the cluster, and then how my pipeline goes. But with LLM-d, Cedric, I go back to you. Can you briefly explain to us, if somebody running LLM-d in their local environment or in the cloud, or some of the integration you have, what could be the developer workflow?
Yeah, and I'm glad you mentioned KitOps. So that's pretty cool. My former boss's boss from here at Red Hat is actually the founder or co-founder of KitOps, and I think they just got accepted to this CNCF last KubeCon, if I remember correctly. So yeah, KitOps is a cool example, and it's really cool. They have this model kit file, and they make it easy to package your AI models, right? LLM-d, on the other hand, is also kind of easy to use, because at the end of the day, it's using the vLLM engine, which is OpenAI compatible. So if I'm building an application on my local machine, and I'll eventually put it in a container and put it on Kubernetes, well, I'm calling the same API the entire time. So it's that OpenAI spec, which is that request or completion or whatever you'd like to use on that V1 endpoint. So it's pretty fun, because I can use the same API if I'm doing inner loop development, or if I've built and pushed my container image with my application, and then it takes advantage of those additional features. So let's say, let me give a good example, some type of agentic behavior in my application. So maybe I have some calls with MCP servers, the tools to a Postgres database, and every time we're using that tool, it has some type of prompt template using some MCP features. So it says, hey, you are a Postgres expert, right? I need you to go into this specific collection and work with data here. Thing is, if I'm just running a container with my inference server and I have to scale that up with a new container every time, we're going to lose that cache right there, right? So we're going to have to process that beginning of the prompt template every single time. And what happens if we're making, we have 5,000 users and they all want to know, I don't know, like some specific collection or information, right? They want to know, hey, what is some data about a specific customer, right? They're all asking the same question. Well, why process that information again every single time? So if we're using LLM-d and the capabilities to spread out the KV cache and to scale up those replicas and to keep that in the memory of our GPUs, then we can really speed up the inference time, but then also like reduce the cost of inference, right? Because we're not going through that entire prompt. We're able to just process that new information, and I think that's prefix caching. And so as a developer, I'm building my app, and I don't have to worry about any of that. On the ops side, on the platform side, that's already handled by LLM-d. So it's kind of a win-win situation for the developer. Hey, I'm just calling this API. And then on the platform side, hey, I'm just scaling up and adding new GPUs, NVIDIA hardware. And I think Nuland, actually, when you were running it, you did an experiment with how many GPUs? It's something astronomical.
A lot. More than I care to admit. But no, that's the beauty of it, especially when you start getting into some of these larger clusters of like A100s that we see in some research labs, or larger Fortune 500 companies. I think for me, I got up to like 50 plus kind of large GPUs going on an experiment at one point. But you'll see some of these data centers that have hundreds of these types of, if not thousands of these types of GPUs configured. And I think this is where I'd mentioned the well-lit path for routing, but another main thing of LLM-d is the ability for it to split these workloads, what we call disaggregated prefill. And we can take the start of the process of an LLM. So the first part of an LLM, I won't get too technical here, but I kind of have to describe it a little bit. When an LLM takes your prompt, it's going to go over all that information at once. It's got basically one process through everything, and it creates that initial cache structure, and basically formats all the data in a way that it will be used now for what we call the decode. What we actually find is that prefill can actually be done pretty effectively on CPU, and it also doesn't really need to scale as much as the decode phase. So that's actually where we've actually created the prefill as its own container, its own pod, and the decode as its own pod, so that we can scale the decode further at a higher rate, and also provide it access to GPUs. And if needed, you could actually bind the prefill to a CPU. It still operates better with a GPU, but we just find that compared to the decode phase, it's a little more CPU friendly if that's the type of optimizations that you're looking for. And that's really cool. So when that's like the first well-lit path. One of our other well-lit paths is also when we got into that expert model I was talking about before, where with models like DeepSeek, for example, we have all these experts now that can be also assigned to their own nodes. And this is really cool, because then you can have a single prefill or a couple prefills waiting, and then have different decodes that are then tied to different experts, and scale that across your entire data center. This is really effective also when we're starting to get into larger models like DeepSeek. Some of the larger ones that we've seen from Quinn, Mistral, Llama 4 has a large mixture of experts model as well. And the trend that we're seeing, there's definitely a place for smaller models, and I think a lot of the research right now is around how we optimize around those smaller models. But these foundation models that are in the 600, 700B side, we see them growing and growing. They just keep growing. And especially when we start talking about larger context sizes too, this is where being able to split everything up effectively, like LLM-d does, makes it extremely more optimal for our end users, and it makes it a lot better costs. We are actually seeing significant cost savings tied to a lot of these approaches as well when we start splitting it up, because now GPU idling, you don't have this big container over here that's hogging the majority of your GPU, because it needs to save it for a variety of different workloads that may not be triggering all at once. Well, now you have it disaggregated, where it's basically going to use what it needs, because it's now been sized correctly based off of those resources. So I think this really goes into the heart of what LLM-d is about, what it's doing for Red Hat customers, what it's doing for the community as a whole within Kubernetes. It's really exciting. And even more exciting is, we know that this is already being used within Google Cloud and IBM Cloud. Both are using these techniques now from LLM-d within their data centers. And, we even saw with NVIDIA, some of the changes with Dynamo, a lot of what's happening within LLM-d community is now moving out into other industry products like Dynamo, for example, with its distributed functionality.
Absolutely, 100%. But thank you very much. I love the conversation we have. Just a rapid fire and a quick question for you before we wrap up the discussion. So can we expect to see in the near future the project like LLM-d will be available in the cloud marketplace? Is it yes or no? Anyone?
I'll take a stab at that. Absolutely. I think it'll start becoming critical for... I think the first adopters are going to be larger organizations at first, who are running a lot of these models themselves, that have the GPU capability, either on-prem or in the cloud. But as the affordability of these models keeps growing with the advancement of technology, LLM-d isn't going to go away. I had one researcher describe LLM-d as a 2025 project meant for 2027.
Awesome.
And I think we're going to continue to see it grow, especially the conversation around AI sovereignty grows, where we want to be able to have control of where our models are deployed and how they're deployed. LLM-d gives the observability and SLO management to make those guarantees that are going to start coming up in audits here in Europe, in Asia, in the United States. There in the Middle East, this isn't going to go away. It's only become a stronger conversation point. And LLM-d is going to be the technology that's going to be powering that guarantee that we are running our assets, we're splitting it up, we're distributing it, and we can run it where we need it, and we can guarantee it's running where it's supposed to be running. And that's all being powered by LLM-d and Kubernetes together with the different distributed technologies embedded in both those projects.
Awesome. Thank you. Wonderful. I would love to see this, because I think currently we're in a dire need of these kind of a solution as well. And we have just a few more minutes left. So Cedric, very quick, how can people contribute to the LLM-d project, and how can they be jump into the community call? Is there a way to do that?
Yes, absolutely. So I'm very glad you asked. So if you go to LLM-d, so it's LLM-d distributed.ai. That's where you can learn more about the architecture, how it works, and then how to actually install it on a cluster. So it's a collection of some CRDs that you'll install, Inference Gateway, API. I think 𝐂𝐞𝐝 is the default, but think about Istio, and there's also the community call. So right now it's a collection of contributors from Red Hat, from Google, from Microsoft, from Hugging Face, NVIDIA. Like it's a really vibrant community. And there's also a Slack. So there's a developer Slack you can join and join the weekly meetings. And there's a mailing list. There's X, LinkedIn, everything so that you can stay in tune with where the project is going and contribute to it on GitHub, because there's learning paths. There's also a quick start in order to install on your cluster. Make it easy, and let us know what you think. Right?
Absolutely. Thank you very much, Cedric and Christopher. I think we should definitely do more of these episodes as well, because LLM-d, more conversation is, I think it's not a justice for the project like this to do a small conversation on this project. So I will be actually disturbing you again. Sorry for that. Both of my
That's fine.
To actually have some more use cases around that as well. And also how the OpenShift customer and the things of the Red Hat technologies have been using integration with the LLM-d project as well. But thank you very much for your time, your commitment for telling the project as well. And we'll look forward to meeting you again in the near future.